Well, hi students. I want to send you this mini lesson because I know it's a Friday and I've assigned a lesson 7.04. Inside of it, it talks about radians. So maybe you've seen them, maybe you remember them, maybe not. This part on your own, you get to practice these ideas. So let's practice them together, but hopefully you've worked through the lesson to the best of your ability, at least learning, taking some notes. I wrote down some notes I'm going to use. Instead of Googling them, I used the course. And then we're going to practice on our own. So an angle measure is 570 degrees. It's drawn in the standard position. So that means the terminal side, right? So let me draw it. So what quadrant, so inside your course, they would have had you explore. You would have had a little GeoGebra applet that let you explore. So we're given the coordinate plane. The standard form is the terminal side is right here. Oh, I might be saying that wrong. See, it's important. So that's not the terminal side, that's the initial side. Then you measure it this way. Boop, 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 boop. And it makes sense that there's 360 degrees in a circle. So this would all be broken down into fourths, right? This would be our first 90 degrees, 180 degrees, 270 degrees, 360 degrees. So if I don't have the applet and I just kind of have to visualize, I would use paper. I would just kind of start here and go, okay, there's 360 degrees. Then this would be 360 plus 90, 450 degrees. Yeah, that's right. For some reason, my brain doesn't. And then plus another 90 would be, why my mental math? That's all right. That's why we have tools. 360 plus 90 is 450 plus 90 is 540. Okay, so we're here now. And then plus 90 would get me back to 600. So I know I'm in here somewhere. So my terminal side should now lie, and we can remember our quadrant. This is quadrant 1. This is quadrant 2. And those are Roman numerals, quadrant 3. And this is quadrant 4. So we should be able to type quadrant 3 and check our learning. We could be wrong. It's okay if we're wrong. That's it. This part is check on learning, check on the vocabulary, see if it makes sense to you. And if it doesn't, the neat thing is, okay, let's talk about this one. Angle measuring 3.6 radians. I don't remember the notation for radians. Is drawn in standard position. In what quadrant will the terminal side of this angle lie? Well, now I want to actually use what they taught me, which is that if this is the radians, I can use the conversion rate of 180 over pi to figure out what it is as a degree. So I'm going to type 3.6 parentheses 180 divided by, and you should have a pi button. If not, you just do 3.14. That should be fine. That should be close enough. Okay, so then this is the conversion, which talked about this in the lesson. I have that written down. This is the conversion rate. This is the strategy that I would like to use to solve. You might have thought of a different strategy working through the course. Okay, so it's approximately, and you can use the approximate symbol, 206 degrees. So again, I just take a look at my circle. This is the initial side, which of course the vocabulary word went through my head and I didn't write it down, but it's okay because we can review. That's 90, 180, right? This measure of angle 180, 270. So it's going to be again in quadrant 3. Excellent. Oh, so as a decimal, oh, look at that strategy. If we write the unit circle, I just wanted to convert because that's part of the notes I wrote down in some of the practice problems earlier, but look how they help us. So now we have this unit circle. right? And they talked about it in this lesson also. It's how we came up with radians, right? The radians are this arc length, and it's approximately 57 degrees or something. Okay? So now we know this. We could use this method if you prefer radians. I prefer degrees. It's my default 0 initial or 2 pi because it went all the way around. This is pi. Makes sense because 2 pi represents the circumference of a circle. 2 pi r? Yeah, 2 pi r should be the circumference. So in a unit circle, the radius is 1. Again, they went over this and I skipped through some parts of the lesson. I took some notes to see it, but it's more of an example. So they talk about all of these questions in your course. So the radius is 1, the circumference is 2 pi r. So this is how we get our unit circle. This is where it's coming from. Sometimes that's really helpful when it comes to understanding. Boop, that's 1.5 pi and then 2 pi. We now have the circumference of our unit circle where this length, the radius, is equal to 1. Now, all of the degrees, or where the quadrants lie, would be a great way between 0 and pi over 2 and 3 pi to 3 pi over 4, which is what they showed you up here. This is approximately pi. This is 3 times pi divided by 4, approximately. And that radian measure is between those, so it has to be in that quadrant. All right, keep thinking. Okay, next question. What's the equivalent? Okay, so here you go. What's the equivalent degree? Really, you just need your calculator here. The pi's are going to cancel because the conversion rate is 180 over pi. I have it written down. So you end up with 5 divided by 3 times 180. Wow, 300 degrees. I don't know if they wanted us to do it a different way, which you could try. Woo! Oh, no, there you go. See how useful this is? Nope, I'm going to let you try it. Ooh, so how would we go backwards? If I have 310, would it make sense to multiply by pi over 180? Let's try it. Terms of pi. Okay, so 310 divided by 180. Okay, so they don't want us to do that. So 31 over 18 pi. I wrote it as a fraction, basically. I put this over 1. I could be wrong. 31 divided by 18. Leave pi in there, so where's pi? Do you see pi? Oh, there it is. Okay, so again, that's just the reverse conversion rate. So if I'm going from degrees to radians, it's pi in the numerator and 180 in the denominator. So you multiply this over 1. And then you end up with this fraction, 310 over 180 pi, because they said leave pi in the answer. Then you divide out the zeros, and 31 is prime. So a prime number only has 1 in itself, and 18's factors are 3 and 6 and 2 and 9. It's not prime, but 31 is prime, and it's not a multiple of 31. So we're done. Okay, cool. Negative. This is important. So we'd have negative. There's a problem here, times 180. I don't know if they want it like this or if they want it in the, oh, okay. So there's no problem. You just use it the exact same way. I was just curious because sometimes, and here, this can be the confusing part when we get further into trigonometry. Say this is positive, let's say 45 degrees. Okay. It is also negative. The same relationship is also negative. I'll do 360 minus 45. This is also negative 315 degrees. So that'll come into play later on, but it's something just to keep in mind how, yeah, there's just like there's multiple representations of the same spot in the unit circle. Okay. Okay. In Roman numerals, express your answer in Roman numerals. So let's take a look at what they taught us with the unit circle. So we know this is 2 pi. And this is pi over 2. We're going to try it this way. This is pi, 180 degrees. This is 3 halves pi. Negative 10. So this is approximately 7, 6, 2 times, where's pi? There it is. If you have a calculator like mine, you have to hit the second button and above that caret key. This is approximately 6.28. Let's see, second pi divided by 2, approximately 1.57. This is approximately 3.14. And then this is approximately 4.71. Now we're looking for negative 10. So let's kind of go backwards a little bit. So we'll start here. We're going negative. So this would now they're kind of flip-flop. This would be negative 1, negative something, something, something. I know I'm at least going to make it over another circle, negative 6. So now let's keep going back. Okay, so it should be in this quadrant. Nope, wait. Nope. See, I confused myself. It's down here now because we went backwards. It only increases by that. So 6.28 plus 1.57. Nope, this is still only negative 7.85. Let's come over here. 6.28 plus 3.14. 9.2. Okay, nope, not quite. So now this would be 6.28 plus 4.71. All right, so that's between here and here. It's between this and this. It's somewhere in here. The line will somewhere be in here. This is quadrant 2. So if they're asking for Roman numerals, it should be 2 capital letters I. But there you have the strategies. Thinking about what the question's asking. I know we could be wrong. All right. I'm kind of hoping I get one wrong. So you see, it's not that big of a deal. Hey, share more. Let's see what happens. Wow, they don't show you. Okay. It's all right. Okay. 360, 180, 270. So you can just try to figure this out. You're right. This is just important. You can just guess. I think it's going to be in 360. I think it's going to be in quadrant 4. Just by guesstimation, just how we spin around. Oh, look. That's a very much more elegant way, a mathematical way. See, what a great place to explore. Oh.
Mommy, do you know where you put the vanilla yogurt?
Okay, there you go. But anyway, that's what this course is used for. And you can keep trying this. Those are the ideas. Oops, radians. Oh boy. All right. Thanks for watching. This is your little mini lesson for 704. I hope it helps as you learn these ideas independently. Think of this as the homework. Lots of schools now are asking you to complete Khan Academy, and then we see the score, IXL, and we see the score. This is our system. So this is for you to learn and check on learning, and then for you to be like, hey, you come to class ready with those questions, with this background knowledge. All right. Thanks for watching.